Hello everyone. Welcome to our channel. In today's video, we will design the layout of latch using Microwind. The practical is from VLSI CMOS Design Lab of JNTUH curriculum for ECE department. In the earlier experiments we used DSCH tool to generate the Verilog files. These Verilog files were used for area-optimized layout by Microwind tool. The Verilog files generated by the DSCH tool used the standard primitives for gate-level modeling. For more complex designs, drawing schematics can not be an easy task. In such a condition, we can develop a Verilog code based on data flow modeling. This allows a digital system to be designed in terms of its function. Data flow modeling utilizes Boolean equations, and uses a number of operators that can act on inputs to produce outputs. Operators like plus, minus, double ampersand, exclamation mark, tilde, vertical slash, greater than and curly braces. In this experiment we shall implement 4-input And-OR-Invert gate in Verilog HDL using data flow modeling. We shall simulate the Verilog design through a test bench using Xilinx Vivado. We shall include the input patterns used in test bench as comments in the RTL code of AOI gate. We shall use this Verilog code for layout in Microwind. This process will help us understand the cycle of CMOS VLSI design at a higher level of design process. So let's begin. Before running the simulation in Xilinx, we'll create the RTL for a 4-input And-OR-Invert gate and the test bench. For the RTL code and test bench, go to our blog, linked in the description. Search for the blog and scroll down to find the code. Copy the code and create a text file in the RTL folder. Paste the RTL code and copy the name of the module. Rename the file with the module name and add the extension .v. This will create the Verilog file. Next, go to the blog and copy the test bench code. Create a new text file in the test bench folder. Paste the test bench code and copy the test bench module name. Rename the file with the test bench module name and add the extension .v. Now, we will simulate the RTL and test bench using Xilinx Vivado. Click on the Xilinx Vivado icon to open the tool. Once Vivado is open, click on Create Project. Click Next and name the project AOI_Gate_Lab 12. Navigate to the appropriate folder and click Next. We'll add the code next, making sure not to check, do not specify sources at this time. Click Next and then Add Files. Go to the RTL folder and add the RTL file. Go to the test bench folder and add the test bench file. Specify that the test bench is used only in simulation. Click Next and skip adding any constraints. Click Next again to use the default component. Click Finish to finalize the project creation. Once the project is created and the files are updated, click Run Simulation and select Run Behavioral Simulation. This will run the simulation based on the test bench. After the simulation finishes, click the Restart button to restart the simulation. We will run the simulation for 160 nanoseconds. Click the icon to run through the given period. Click Zoom All to see the simulation result. Verify the operation of the 4-input And-OR-Invert gate. This verifies that our Verilog file is created properly. In the simulation, we can see that input D toggles every 10 nanoseconds. Input C toggles every 20 nanoseconds. Input B toggles every 40 nanoseconds. And input A toggles every 80 nanoseconds. We have stored this information in our RTL code as comments. All inputs are simulated as clocks, and their on and off times are mentioned as comments in the RTL file. This will help in layout simulation. Now, we shall convert the RTL code to the layout using Microwind. Open the Microwind program by double-clicking on its shortcut. Once the Microwind is open, go to File tab and click on Select Foundry, to select the 0.35 micrometer foundry. Next, go to Compile tab, click on Compile Verilog. Go to the Verilog file by navigating to its location, selecting it, and clicking Open. After viewing options such as metal layers, click on the Compile button and then return to the editor. Notice that Microwind has created an area-optimized And-OR-Invert gate layout. With all voltage supply and output configuration set, add a VDD connection to the N-well region. Proceed to simulation by clicking on Run Simulation button. View the output, which varies according to different enable signal values. Observe that the output of layout simulation matches that of the schematic simulation. Check the minimum and maximum frequency by clicking on Frequency versus Time tab. Click on FFT to view the operation frequency. Click on Back to Simulation to close the FFT window. Each time you adjust settings in Microwind simulation, remember to reset by clicking the Reset button. Press the Reset button to see the power consumption. Save the layout as AOI_gate_lab12.msk for future. This concludes our design of And-OR-Invert gate using Microwind. For more details about the practical, visit our blog. All the source codes are available. Do not forget to subscribe our channel and hit the like button. Until next time, happy coding. Thank you.